Okay, so let's take on another example here to verify that Rolle's theorem for the given function will work and that there's a value c within the interval from a to b such that f prime of c is equal to 0. So, all right, this one looks a little bit more difficult, but it's certainly one that we can handle. There's a little bit more work involved in terms of our derivative, but let's take a look. F of x, well, let's verify the continuity here. First of all, even at negative 1, f of negative 1, that's equal to 0. Right? You can verify this for yourself by substituting in negative 1, but you see that we take the square root of 0 right there. We could also verify that the continuity is true, at least because at the left-hand endpoint of this interval right here, the function's limit as x approaches negative 1 exists, and they are both equal to 0. And then we try f of 0, and of course, yeah, f of 0 is also equal to 0. Again, you can verify this within the interval. So it looks like we're so far so good, and that the function is continuous on the interval from negative 1 to 0. Next question is f of x differentiable on the open interval from negative 1 to 0? So we're going to find out here. We should rewrite f of x in such a way that it makes it a little bit easier for us to find the derivative. In this case, looks like we're going to have to use a product rule and a chain rule. We've got negative 3x times x plus 1 to the 1/2 power. So when we take the derivative, f prime of x should be a derivative that exists everywhere on the interval between negative 1 and 0, but not necessarily at negative 1 or 0. So if we use our rule, that means it's negative 3 times the derivative of x, just negative 3, times x plus 1 to the 1/2 power. And by the product rule, we add to it the first function, negative 3x, times the derivative of the second function. In this case, by the chain rule, that's going to be 1/2 times x plus 1 to the negative 1/2 power times the derivative of x plus 1. Well, that's just 1. So let's rewrite this a little bit. F prime of x is really the same thing as saying negative 3 times the square root of x plus 1 minus 3x divided by 2 times the square root of x plus 1. All right. Now we might ask, well, where's f prime of x anywhere undefined? Well, we know that it's undefined at x equals negative 1. But again, we just want to find out, is f prime of x differentiable over negative 1 to 0, not including those endpoints. And we can certainly say that f prime is defined for all the values between the endpoints. So over the open interval from negative 1 to 0. So even though it's undefined at that one point, we can certainly say that it is differentiable over the open interval from negative 1 to 0. So actually, we've met our conditions for Rolle's theorem being able to apply. So let's check it out. That means that there has to be one point within the interval from negative 1 to 0 such that f prime of c is equal to 0. So now our next task would be, well, let's see if we can find a point c such that the derivative is equal to 0 within the interval. So we set our derivative equal to 0, and let's find out what we can do with it. Let's see, I've got negative 3 times the square root of x plus 1 minus 3x divided by 2 times the square root of x plus 1 equal to 0. So we can move constants over right here. Let's see what we can do. We can move over our 3x square root of x plus 1 over, let's see, and set that equal to negative 3x over 2 times the square root of x plus 1 Well, let's see if there's anything that we can do with this, because it looks like we're getting a negative, but maybe there's a value within the interval from -1 to 0 that'll work right here. So let's multiply both sides by the square root of x, 2 times the square root of x plus 1 to eliminate our denominator. So I multiply by 2 times the square root of x plus 1 here, multiply 2 times the square root of x plus 1 here. I end up with the quantity 6 times x plus 1 is equal to -3x. That is to say 6x plus 6 is equal to -3x. If I subtracted 6x from both sides, I would get 6 is equal to -9x. And dividing by -9, I get x is equal to, when I reduce the fraction, -2/3. Now, does that fit the bill? Well, certainly. -2/3 is in the interval between -1 and 0. So c equals -2/3 is the kind of value where the function f of x would have a derivative equal to 0 on that interval. Again, we verify Rolle's theorem using this method.